And okay, great. So we'll begin. We're recording now. So just want to get started and say thank you all for coming and joining us today. We're very pleased to offer our first Sloan Indigenous Graduate Partnership webinar. Our title for our program is called Building a Community for Indigenous Graduate Students at Purdue University. And we do have a variety of speakers that are here to join us, and we're excited to get started. So as we begin, as I always do with our Native American heritage programs, is to offer a land acknowledgement. And we're very pleased to finally have our land acknowledgement on our website. So if you have a chance, you can take a look at that. But for me as a Native woman, as a Navajo woman, I always think it's important that we try to make sure that we're teaching people about the different places where we're at and places that we come from. And being here in Indiana, the land of the woodland Indians, such as the Potawatomi, the Lenape, the Miami Shawnee, and some additional tribes, I always want to make sure that we acknowledge and we offer our gratitude for the original caretakers that were here. These were people who laid the groundwork before Purdue was established, or even before the state of Indiana was established. And so we just want to make sure that we offer our profound gratitude. As we get started with our presentation, I have a quick overview here. We have Kevin Gibson will be offering a history and overview of the Sloan program. Ken Ridgway will offer some insight into our student research and faculty participation. We're very pleased to have two of our students, scholars that are going to be joining us here today. And then we're going to close out with an alumni perspective when we have RaeLynn that's going to be coming to join us. So with that, I'm going to go ahead and ask Kevin to go ahead and start this process. I'm going to go ahead and start with the first slide. I do want to also make sure that we do have some questions that we're going to answer at the end of the presentation. However, if you're interested, you can start putting them in the chat. Deb Swihart is managing our chat box, and so she'll be able to offer those questions beforehand, but hopefully we'll have your questions answered. Okay, Kevin, I'm turning it over to you.
Oh, can't hear you.
I think you're on mute, Kevin. There you go.
Yeah.
Yes, now I am good. You would think after the hundreds of Zoom calls, I would have figured this out. Anyway, thanks Felica for organizing this and for getting us started, and good evening, everybody. So the Sloan Indigenous Graduate Partnership is a partnership with the Alfred P. Sloan Foundation and 9 institutions, including Purdue. And the Sloan Foundation has funded us to increase the number of Indigenous graduate students, graduating with advanced degrees in STEM disciplines. And the first SIGP began in 2001 at the University of Arizona, or I'm sorry, in 2003 at the University of Arizona. And since then, 8 institutions have joined to create a program with a national reach. And you can see that we have partners with 3 universities in Montana: University of Montana, Montana Tech, Montana State University, the 2 universities in Alaska, University of Alaska, Anchorage, University of Alaska Fairbanks, and then 2 recent additions, the College of Environmental Science and Forestry at State University of New York joined us in 2019. And then the University of North Carolina, Asheville joined us in 2020. And the Asheville program is the first program that the foundation has supported at the undergraduate level. The other bullet points on this are really to indicate that in 2014, previous to 2014, the programs had largely operated independently. But in 2014, the foundation brought us together to form a single national team. And since then, we've had our funding renewed now twice. The most recent one, a large grant, large 4-year grant, one of the first 4-year grants that the Sloan Foundation has ever granted, that allows us to continue this work until 2024, where hopefully we'll be up for renewal again. So the national program has over 200 alumni, and we average nationally well over 100 students enrolled each year. The Purdue University joined in 2007, and since then we've recruited 60 students, and we have 38 alumni and 18 current students. And of those students, however, 6 of the students started as masters and have gone on to have either gotten a PhD or working on their PhD. One of the things that we're particularly proud of at Purdue is that 94% of all the students who 94% of all of our students have either graduated or are still enrolled, which is really a remarkably high rate of completion for any sort of program, but particularly for a program working with underrepresented minority students. So the way that this works is that students get nominated by the Purdue SIGP leadership, and we nominate them to the Sloan Foundation. And to be eligible for consideration in the program, an applicant has to be a member of a tribe or Alaska Native village or a Native Hawaiian on the Native Hawaiian registry list. We will also review applications from students who can document a connection to an Indigenous community. The student has to be a US citizen, and critically, they have to be accepted into a STEM graduate program at Purdue. Now, Purdue provides for all the students who are accepted into our program. Purdue will provide tuition and fees, usually in the form of an assistantship, but sometimes in the form of scholarships or fellowships. And then the foundation provides additional funds directly to the students. And the current level of funding is $20,000 for a master's student that might be paid out over 2 years, or $40,000 for PhD students that might be paid out over 4 years. So roughly, the students at Purdue, in addition to the stipend that they receive as a part of an assistantship, receive about an additional $10,000 a year. For most students, this puts them in the range of $30,000 to $35,000 a year for funds, plus the value of the tuition and some fee that are covered by the university. The cost of living in West Lafayette is relatively low, so this is a pretty competitive financial package. And students can, as I said, can be accepted into any STEM discipline. And we've had students in the program from campuses and programs all across the university, ranging from wildlife biology to engineering, a number of students in geology or the Earth, Atmospheric, and Planetary Sciences program, but also in biology and ecological sciences, computer science, statistics, horticulture, and math. And so I think I will stop there. I think that's in my 5-minute time frame, and then I'll hang on to the end to take questions.
Okay, thanks, Kevin. So we'll go over to Ken.
Hello, everyone. I'm Ken Ridgway. I'm a faculty member in Earth, Atmospheric, and Planetary Sciences. And so I want to talk about some of the lessons that we've learned from the SIGP program here at Purdue. The first one is that Purdue can attract Native American students in STEM areas. You can see from Kevin's presentation that we've had a number of students from a number of different areas. So it's really a myth that Native American students are interested in the STEM disciplines, but there's some context to that statement. And there's some things that we've learned to help students be successful within these STEM areas at a Research One university. The first point I think that we've learned and we've been taught is that Native students often want to have some type of research that impacts their communities. Their research might not directly be on their native land, but it has to have some context that they can take back home. We've been fortunate enough to travel to many Native American communities, and we ask elders and community leaders, what are the big issues? And it's things like climate change, water issues, forestry management, sustainable agriculture, wildlife management. And these really become questions about sovereignty, like who makes decisions on native land? Who collects the data? Do they collect that data with any kind of respect for native culture? And so these are all key questions about who gets to work on native land and how they work on native land. And so it becomes really important that you have these partnerships with native communities. A third point is that when native students come to Purdue, they don't leave their culture behind. And this is a hard thing sometimes for Research One universities to understand. And so we've had 2 students from the Eastern Band of the Cherokee, and we brought elders up to the center. And so it's a way to build these connections with the communities, because again, the students aren't going to leave their culture at the door when they enter a Research One university. And another key aspect is that you really need to match the students with advisors that are going to be flexible and willing to learn, or at least respect native culture. So kind of an example that we often use when Kevin and I are talking with graduate committees about recruiting Native American students is that student might want to be home for a ceremony. That ceremony might be much more important than being home at Christmas time for the traditional mainstream student. And so that becomes, an advisor has to understand that, and that might not fit with the time schedule for key meetings in their discipline. And so they have to be aware of that. There's also going to be a lot of challenges for Native American students at R1 universities. These universities weren't built around accommodating Native American students. Often they don't know very much about our cultures. They often don't even respect our cultures because they've never been taught them. And that's where the SIG program becomes important, because we can try to help Native American graduate students navigate through this white power structure that the universities are built on. And so that's where it becomes important again to match students with good advisors, or at least advisors that are willing to learn. That's where it becomes important to helping students maintain their connection with their communities, because again, you can't change the way that you're brought up. You don't leave that when you walk into a graduate program. Often these students are the only Native American person in their lab. And so they're under a much different context than a typical graduate student. And the Sloan program also is important because it helps with the finances. So we've had single parents, we've had people that had to put again made a big difference by allowing students that might not come from a background where there's funds available if your car breaks down or you need to pay for your insurance. And so it helps to take that edge, the financial edge off of being in grad school. Another key point from our perspective is that, and this is what we talk with graduate committees about, is looking at Native American students and evaluating them on their potential rather than their pedigree. So a lot of Native American students might take off for a semester because they have to help their family, or they just don't have the funds, or their car broke down or whatever. And so to compare that student with someone that's come from a very privileged family that went to coding camp every summer and went to math camps, doesn't mean that the potential's any different. So you have to look at that application and get to meet the student and really get to know their potential as a leader and as a scientist, if you really want to evaluate them fairly. The last couple points are that summer bridge programs are very important. We have found we've had a number of students that were very cautious about coming to Purdue. Again, it's a predominantly white institution, very far from their homes, and those summer bridge programs were really key for for them getting to know what it's like to live in Indiana and to be at a R1 school, but it also gave their advisors a chance to start a relationship with them. And we've had some students that have said, I'm not coming back. And so, but that's okay. What we want to do is put people in opportunities where they can be successful. But the summer bridge programs are a way for both parties basically to get a feel for how this might work out. And the last point I would say is that we know that the cultural centers are really the key, because again, it ties into all these different elements that I'm talking about that you don't have to leave your cultural upbringing at home, that there's places where there's a critical mass of Native students where you can come and be Native and talk about Native issues. There's a place where your elders can come and meet you and talk with you. And there's this opportunity to talk about Native issues. So I think that's some of the things that we've learned as a program, and we're still learning, but we think that's what's helped make it successful, in addition to all the hard work by the students. So if you have any questions, I'll be around at the end of this conversation.
Okay, thanks, Ken. I'm going to go ahead and see if Taymee, are you here?
Yes, I'm here. I got my
Okay.
internet back working, so thank goodness.
Okay, great. Well, we were texting back and forth because she got kicked out of her internet. So I'm going to go ahead and stop sharing and share, and I'm going to hand it over to Taymee for her presentation. So here we go, Taymee.
All right, well, I wanted to say hello. Nice to virtually meet you all. My name is Taymee Brandon. I'm a second-year environmental engineering PhD student here at Purdue University. I'm going to work to share my screen, and then I'm going to shut my camera off to prevent any further interferences with my internet. But alrighty. Can everyone see that okay? All right. So my current working title for my research is Trivalent and Hexavalent Chromium Removal from Tannery Wastewater in Arequipa, Peru, using surface modified and unmodified biochars. So my research is co-advised by Professor Jaffert and Professor Hua here, and is funded through the Arequipa Nexus Institute, which you can see the logo to the right, through Discovery Park, which is a collaboration between Purdue and UNSA in Arequipa, Peru. And my personal funding sources are through the Sloan Indigenous Graduate Partnership, the Purdue Doctoral Fellowship, and the Gates Millennium Graduate Scholarship. So I wanted to start with a little bit about me and my story. So I am a member of the Turtle Mountain Band of Chippewa Indians community, and I'm from Montana. So I was born in Havre, which is up here on the High Line near the Rocky Boy Chippewa Cree Indian Reservation, which is sort of a smaller one in Montana. So most of my family lives in this area here, and then I later moved to Great Falls, where I graduated high school and then went on to do my undergrad in Missoula, Montana, where I received a bachelor's in chemistry in 2016. So I've always been passionate about science and water quality, which has led me on my path in research and academia. And I was inspired to go to Montana Tech in Butte, Montana, to do a master's in environmental engineering. And a large part of that was due to the presence of the Sloan program there. I had initially thought I was going to do a PhD in analytical chemistry just right away, but the water quality focus and then the Sloan program sort of sent me in a different direction. And during my master's, I worked on an environmental microbiology project related to eutrophication or algae blooms. So that entailed engineering bioelectrochemical denitrification systems to remove excessive aquatic nitrates to help with combat eutrophication. And this was followed by DNA analyses to learn more about the biofilms and how they work. So it ended up being really cool. And my work culminated in my first authored published paper in a journal, and also receiving my master's in environmental engineering in the spring of 2019. So I essentially have lived all over Montana and knew that I wanted to pursue a PhD following my master's. And I was accepted to a number of universities, but I ended up being compelled to come to Purdue also due to the presence of the Sloan program, because I found that to be so beneficial during my master's, and I felt that that would be a good decision in coming here, and it's turned out to be true. And so being in the program, I think one of the biggest benefits to me is just being able to have a community of people with similar upbringings when you're away from home, because it's really difficult if you feel like the only small fish in a big pond. So here are some pictures of Montana. It's gorgeous, of course, but these are a lot of the different places I've lived and grown up. I showed a map, so I thought I should show some pictures too. Also, so this is my family, or at least some of my family. So I started with a slide with only a couple of pictures when I first made this, and it has expanded. I have 8 brothers. Some are pictured here, 9 grandparents, so many like uncles and aunties, and even more cousins, so they can't fit all in one slide. But I'm grateful for all of their support and helping me get to where I am today. So delving into research and what I'm doing here at Purdue. So leather tanning is considered to be one of the highest industrial polluters, notably due to its large concentrations of chromium present in the wastewater. So chromium is toxic in the natural aquatic environments, and the figure to the left is a generalization and depicts the stages of tanning. So I won't go into detail, but along the way, there's a lot of different stages of wastewater streams at multiple steps, which causes a lot of problems in the environment. So the leather tanning is not new. There's evidence going back to as early as 3300 BCE, where it was used for armor, shoes, parts of carriages, etc. But the addition of chromium did not begin until around 1840, when it was discovered that the addition of chromium salts like chrome, alum, and chromium sulfate create a stabilization effect on the leather by cross-linking the collagen fibers, which is one of the reasons why it's we're so heavily dependent on using this method of making leathers, because it strengthens it, and there's a lot of different applications for it. So in general, Tannery wastewater is a complex matrix of contaminants with high concentrations of the trivalent and hexavalent. So trivalent is a lot less toxic, hexavalent is much more toxic, and of the different chromium oxidation states. It is estimated that around 40 million liters of wastewater is released each year in industry, with high concentrations of chromium far exceeding the maximum permissible contaminant limits in different countries. So in addition to this high amount of chromium, there's a lot of sulfates, bacteria, organic molecules in the wastewater from the hides, and sometimes other heavy metals. So for my work, I have a few samples from the site in Arequipa, Peru, which I'm working to characterize and determine what exactly is present in the effluent. So this image depicts part of the site of consideration that is being studied by our partners in Arequipa, as well as here at Purdue. So the industrial part consists of multiple different tanneries. So some of these buildings are different tanneries. And they all in this area feed their wastewater into this giant oxidation lagoon, which in the pictures, it's like a dark blue. And the purpose of it is meant to allow for evaporation, precipitation, and sort of partial containment of the chromium. But the issue is that these lagoons, even with a liner, that's what they seem to be sitting on top, underneath that is limestone or some porous ground, so that can cause leaching into groundwater and nearby streams. So this particular lagoon in Peru is estimated to have concentrations of chromium that exceeding 1,300% of the maximum permissible limits. So this necessitates some sort of effective remediation strategy to be used. So in order to remediate tannery wastewater, there are multiple different methods of removal. One of the most common is chemical precipitation, which is the addition of lime or other hydroxide salts that cause the chromium and other heavy metals to precipitate or solidify out of solution. So then they become a filterable solid, or at least not aqueous, where they're interacting with water and groundwater. And there are also biological and microbial methods where the microbes reduce the more toxic chromium-6 to chromium-3. So, and then membrane treatment, which works really well, but it's pictured right here. But it's a complicated system and ends up being much too costly for the countries that have most of the Tannery wastewater. And then there's also difficult methods like electrocoagulation. But one promising method that has been explored over the past few decades is the use of adsorbents, which is a seemingly sustainable option. So some of the common adsorbents include, as you can see in this large list to the right, using things like apple peels, sawdust, crawfish shells, or biochar, which is the focus of my work. So in general, biochar is just taking the remaining parts of different processes, for a lot in agriculture. For example, mine is rice husk biochar that is then pyrolyzed, and then it's sort of like a sustainable Brita filter, which is how it works. So the current methods of removal are limited because they do not allow for a cost-effective resource recovery, but biochar has the potential to not only remove the chromium from the wastewater itself, but also recover it and gain some of the around 80% of chromium that is lost in the process. So this would be especially useful in regions with chromium tanning, because like I said, they're in third world countries, so they don't have the resources or the regulations for a clean and streamlined system. And if you can argue an economic value to switching their process, and as well as cleaning the environment, that would be ideal. So the question then becomes, how can this oxidation lagoon be treated? So if nearly 80% of the initial chromium salt is unrecovered, there is a substantial amount that is in need of remediation. This led to the idea of using locally sourced rice husk biochar from Lima, Peru, which will allow for the adsorption of the two dominant forms of chromium, trivalent, which would be, according to my literature review, using unmodified biochar, and hexavalent using surface modified biochars, such as nano zero valent iron particles, or possibly even surfactants, which is what I've been looking into more recently. So the idea then becomes to engineer a biochar filter, possibly a series of filters that can remove the two forms of chromium from the system. Since the system is large and the wastewater as well as the biochar are both complex, there are a lot of considerations to take into account before beginning testing. So some of the things that need to be done, and what I'm working on now, is to characterize the wastewater itself, so we know how much chromium is present and what the ratio of chromium-3 to chromium-6 is, because if there's a lot more chromium-6, it's much more toxic. So I'm working on that now. So next would be, after that, to optimize the filter and the conditions of preparation for the biochars. So doing some small-scale testing and testing the effluent using the standard colorimetric method, and generating adsorption and desorption isotherms to understand the efficiency of the filter. I'd also like to understand more about the surface properties of the biochar, because there's a lot of interesting things that happen chemically at the surface, such as how do the chromium particles interact with the biochar itself? What functional groups are present on the surface modifications? Are there electrostatic interactions? Or, you know, what pH should this be run at if it were to be scalable? So at this point, there are a lot more questions than answers, and I'm working on gathering preliminary data and developing more actionable research questions that can be tested in the lab, while simultaneously having a novel idea that helps advance the science and, of course, publish papers. So that's the goal. So in general, we know that, as with any experimental design, we don't want to reinvent the wheel. So the parts that I've found during my literature search over the past few months would be the most well-studied aspects is the surface chemistry of the different types of biochar used, and the adsorption properties, how the chromium-3 and chromium-6 interact with surface modifications. But what's much less studied is the desorption properties. So that's what I need to keep looking into it, but that's what I would like to focus on and see if I can come up with a method where there could be some resource recovery and economic potential. So since I'm still in the beginning stages of my work, the general direction is to continue characterizing the Tannery wastewater using various instrumentation to gain information on it, like ion chromatography, inductively coupled plasma, instrument and doing colorimetry to test the effluent. And once I have a better understanding of what is in the wastewater, I can begin a small-scale column testing of modified and unmodified biochars, develop an overall method, generate these absorption, desorption isotherms to understand the efficiency of the column. And based on the literature, the surface chemistry is very complex, so some factors that need to be taken into consideration are what is the source, type, and pyrolyzation temperature of the biochar, the ratio of the modification, so the additional nano-zero-valent iron or surfactants to the biochar itself, whether or not the columns are worthwhile and scalable due to the desorption properties, pH, temperature, what's reasonable, but ultimately I just want something that is scalable so there's a larger application that this could actually be used in real world systems. So my current research questions are general since my work is just beginning, but some clear questions that stick out in my research is what is the optimal method of biochar preparation? Can desorption of chromium work on the large scale to provide economic benefit? Can one filter work, or do I need to, where it's a dual system, or do I need to do a series or separate treatments? And so my current direction is based on what is possible to be added to the literature, and if I can come up with a method of desorption and resource recovery. And I think that would be a great basis for publishable papers in the future and working with tanneries. So in a nutshell, thank you.
Yes, thank you so much, Taymee. I really appreciate you sharing your research. I'm going to turn it over to Camille, or as we know her more as Cami. And Cami's going to do a quick presentation about her research project. And I think you should be good to go to share your screen now, Cami.
Okay, let's see. I have to get my PowerPoint up there first. Well, Lila and Petawashte, good day. My name is Camille Griffith, and I am from the Oglala Lakota Nation. I'm getting my PhD in wildlife science from Purdue University, and I actually got my bachelor's degree at Oglala Lakota College. It's my tribal school in, I want to say 2012 or 14, I don't know, somewhere along there. And I got my degree in natural science with an emphasis in conservation biology. When I was going to school there, I was working on a project for ornate box turtles, which is a species of greatest conservation need in South Dakota, and also a species that's sacred to my culture. And so at the school, I'd say one of the good things about going to a tribal school is that I was able to kind of identify as Native American and learn how to incorporate my own culture into research and into education. I guess I liked box turtles so much, I continued it into my master's degree. And I got my master's in integrative genomics from Black Hills State University in South Dakota. And the reason I got that degree was because once I was working on ornate box turtles, it became really apparent that there was very few that actually were in South Dakota. And all the ones that we were able to find were on the reservation. And there's a major road that goes through there. So I was interested to see how anthropogenic threats might be destroying the population there and structuring the population. So from there, I actually went to the National Wildlife Conference in 2012, and I met Dr. Zollner, which is my now advisor. And I had a lot in common with him, especially the idea of using spatial ecology for science and conservation. So from then, I just kept in contact with him. And eventually I decided to come to Purdue for my PhD. And at that time, I also met my second advisor, Dr. Flaherty, which I also had a lot in common with, especially the idea of management and protecting our wildlife. So now I am dual enrolled by both of them, which is great. And I was lucky enough to have advisors, as Ken said earlier, that were willing to let me kind of determine my own project in a way and gave me that amount of flexibility. So I decided eventually to do population control of domestic dogs on the Pine Ridge Reservation, which I will in a little bit explain why I'm so personally involved in this project. Okay, so domestic dogs are found all over the globe. Everywhere that humans have been, domestic dogs have also been found. And then dogs like these ones that are unrestrained by fences or leashes are called free-ranging dogs. They can be categorized into these three major groups: house dogs, stray dogs, and feral, based upon their level of human dependency. But that human dependency varies greatly based on your definition of what you want to use. And with an estimated global population of dogs almost at 1 billion, I would say that they are one of the most invasive species and pose a serious risk to wildlife through disease transmission, hybridizing with wild species, or of course diminishing prey populations. And the economic cost, as you can see, is reaching 620 million. And most of that has to do with damages to agriculture, forestry, or overall the environments. And unfortunately, this is much more common in areas of greatest poverty. And this picture was taken on the Pine Ridge Indian Reservation, where the poverty rate exceeds 90%. That's below poverty. And this can make it very difficult to access veterinary care, animal shelters, or animal control. And actually on the reservation, there is no veterinarians or animal shelters. You have to drive at least 50 miles away to get to one. This is a big problem, especially for myself personally, because my niece Jayla was actually killed by dogs on the reservation. And so I am very much personally involved in this project. After my niece was killed, tribal animal control initiated stray dog roundups and lethal control. And then as a response to that, there was much more push from animal rescues to transport dogs to local animal shelters that were off the reservation in other states. With one rescue, this one here, Lightshine Rescue, reporting over 5,000 dogs being removed from the Pine Ridge Reservation between 2014 to 2018. And then the tribe also had some financing invested in Oglala Pet Project, which did low-cost spay and neutering. But unfortunately, after 6 years after she died, there's really not that much change in the population of dogs. You go on the street and there's still just as many dogs as there were before, in just as bad shape as they were 6 years ago. And now the funding has run out from the tribe for that. So I am personally pursuing a project to find a solution to these problems through empirical science. Let's see. And in order to do this, I'm going to be addressing the issue of management of free-ranging dogs into these four major components. The first one would be defining feral strain-owned dogs. Then it would be identifying key landscape features in which dogs occupy, and then assessing the community perception of dog population control strategies. And then I'll be using this assessment to make sure that the previous objectives are ethical. And then I'll be compiling all of this analysis into a simulation of animal control strategies on the Pine Ridge Reservation, and then use that to determine effective, efficient, and ethical ways of controlling dog populations. The Pine Ridge Reservation is in the very southern portion of South Dakota and includes up to around 2,000 square mile area, and around 19,000 people live in this area, most of which are members of the Oglala Sioux Nation. And then the reservation is split up into 9 major districts, and each of those districts have separate managements. So I distributed community surveys in 7 of the major towns. Each of them are in separate districts. The surveys, I also distributed surveys at Oglala Lakota College and then the Kyle Indian Health Services. And then each of these towns, the human population size was between 3,000 to 100 people. So they're very tiny towns. The surveys included questions around preventing overpopulation of dogs, and then barriers that people may be having to spay and neuter their pets, beliefs on animal control effectiveness, and then just baseline data on safety risks and the extent of the problem. Overall, there was 108 surveys that I distributed. And then on this slide, also these dots right here, I actually set up scent stations at each of these locations. And these scent stations included modified hair snare. So I used Elizabethan collars and then modified it using tape wrapped around it and then board cleaners. And this was to gather hair so that I could kind of identify their diet of the animals. And that would be used as a proxy for human dependency and defining feral, stray, and owned dogs. Yeah. And then I would set them up in the center of the town and then 500 meters spreading out from that center. Here's kind of in action, the dog smelling the scent and then rubbing up against the cone, leaving some hair, hopefully. Okay, so these are different numbers of animals that, different types of animals that I found there, the total identified. So could you imagine like maybe what the dogs are? How many dogs I found based on this? No? Okay, I'll just tell you guys. That's how many. Yeah, 563 identified dogs. It's crazy to me. You know, usually you find cats are the most in an area, but in this case, it was the dogs. It's crazy. So I just, in closing, there's a lot more that I wish I could say. I could probably talk for a whole hour on this, but I'm not going to. So in closing, it is apparent to me that the domestic dog overpopulation is a big problem in my local Indigenous community, but also in communities all over the world. And there's good reason to believe that overpopulation is negatively impacting wildlife on the reservation. And many of the people that I found after handing out surveys know that there's a problem, but just lack the resources to do anything about it. And so this is even more of a reason why it's good that I'm actually making a model to simulate the different animal control strategies that will benefit my community, but also can be used in many other communities, especially in Indigenous communities where there's plenty of res dogs.
Okay, thank you, Taymee. That was wonderful. And would you, let's see, screen sharing. Okay, there you go. Thank you so much. And I'm going to go ahead and turn it over to RaeLynn Butler. She is one of our Sloan alums, and just to kind of give you a perspective as to her time at Purdue and to see how she has used her degree to benefit her people. So RaeLynn, you there?
Hi, can you hear me okay?
Yep, we can hear you.
RaeLynn Butler, Jaho Jifkados, Amalegada, Wakogi, Almadowa, Patukan, Tallahassee. My name's RaeLynn Butler. I'm from the Raccoon Clan, and I'm from Peach Ground Ceremonial Ground, which is part of the Muscogee Creek Nation in Oklahoma. My tribe is originally from the Southeast in Alabama, Georgia, Florida area. And we were removed on the Trail of Tears about 180 years ago to Oklahoma, to Indian Territory. Some big news from my tribe recently is that we won a Supreme Court case the McGirt versus Oklahoma. And the aftermath of that decision has been really rough. Currently, I do work for my tribe, which was my ultimate goal to even go into graduate school. So I'm very thankful and glad to be an alum of this program. And just wanted to share a little bit about how I ended up at Purdue and then where I am today. But it is crazy to think about, seeing Purdue on the news, especially with all the COVID stuff happening recently. And I was lucky to come to campus about a year and a half ago, maybe almost 2 years this fall. And, I lived in Lafayette when I was at Purdue and took the trolley to campus every day or the bus. And I seen all those Lime scooters and I was really jealous about how I wish I could have used those to go up Chauncey Hill when I was a student. I attended Purdue from 2009 to 2012. As some of the professors mentioned, or I did an internship, summer internship right after I graduated, or actually the year before I graduated undergrad, so that I could see what Indiana was like and what the campus was like. And I really enjoyed that, doing a research project. It was through the, I'm sorry, I can't remember the name now, but it was a great program. It allowed me to get experience and understand what it would be like at Purdue. But at that summer, I had studied earthworms and with Dr. Gibson in the botany program. When I finally decided to, and also I attended Haskell Indian Nations University in Lawrence, Kansas, in the environmental science program. I believe when Purdue came to visit our school, there had been no Sloan graduates yet. The first one was about to graduate, which was Candace. And so it was great to meet her and all the other folks that were building this program, and then also to meet Native students that were already at Purdue. And we got to come and visit the campus. And I think, through the summer internship and visiting and the great kind of outreach and opportunities that Purdue was providing, the Sloan program was really seemed to be a great deal. And so I was nervous. I didn't think about graduate school, as a child growing up, even as an undergraduate, I wasn't sure, what path I wanted to take, but that I liked science, I liked plants, and that I know that information could help me somehow benefit my community and my tribe. And so I studied weed science, and my main research was dealing with sustainable agriculture and organic weed management practices in fresh market tomato, and did a few years of field work and did some greenhouse studies, and it was a great experience. And when I graduated, a lot of the people in my cohort in the botany program were being trained to go into industry to work or into academia. And I was really conflicted and wasn't sure that the only thing I knew is that I wanted to work in tribal community, and that, there aren't really a lot of job titles or things associated with weed science, working for your people. And so I think that was a major challenge, is, graduating from Purdue and not having a job lined out or knowing, what was going to be my next step. But I wanted to pursue extension. I thought that I really enjoyed the research part of graduate school, and looked at Indian country extension as an opportunity to help the community and continue to do research. But, looking back, I wish I would have pursued my tribe sooner, or involved a project that included my community, so that my tribe would have been more aware that I existed and that I was, wanting to do something or involved. And so I think early collaboration with the nation would have been something that I would have tried to do more. At the time, I felt that I I didn't want to study anything culturally for me because plants are very, for medicinal purposes or sacred reasons, that I didn't want to exploit those plants or bring to light in the literature how important they were. There's a dark history of researchers coming into Native communities and getting data and never coming back, or people not ever getting that information. And so I felt that I just needed to learn everything that I could in the discipline, and that I could apply those tools or that information in a different way when I returned home. Some of the things that really helped me through graduate school is that I was a very shy person, and I remember Dr. Gibson telling me that this experience is going to give you tough skin, and that I would get out of my comfort zone. And I think knowing that, to defend my thesis, that I had to do a seminar for the department, I think was also something that for the 3 years I was there, I dreaded. And so with the help of the Sloan class, meeting weekly and doing presentations like today of your research, and also preparing for conference presentations at ACES or SACNAS, really helped me build up my confidence and help me get feedback from all over the campus that, to say, hey, it would be better if you did this, or it really helped me, I guess, find confidence in what I needed to do. But so I really appreciate the professional training that I learned, because it helped me in all aspects, not just in botany or in these things. It just really helped me become a better professional. Let's see. Also, project management. I feel like those are kind of skills that you can use anywhere you go, or any kind of career opportunity you may take. I did, when I was very shy, I would say that the success of my Purdue education helped me actually win an oral competition of presenting my research at the ACES conference one year. And so I was really shocked and pleased. And then, upon graduating, I ended up becoming an adjunct professor at Haskell Indian Nations University for 1 year, and helped teach biology courses there. And then I also taught at Tulsa Community College for 2 years after leaving Haskell. So I spent 3 years teaching biology, and the life of an adjunct was pretty difficult, just in terms of having different schedule from semester to semester and not having a really reliable income. Sometimes you would teach many classes and other times you wouldn't teach any. So it was really hard, and to try to get on as a full-time staff there. I did try once and got to, I think to 4 interviews left, and did a teaching session and met with the dean and did all these things. And, the other 3 people had PhDs. So I kind of knew that I wasn't going to be selected, but it was a great experience to understand how that works in academia. But I found an opportunity through the tribe as a librarian of all things, which I thought, I know how to do research and I know how to work my way through a library. I think that this would be great to get a foot into the tribe. And I did that for a few months, and then quickly moved up into the Tribal Historic Preservation Officer. And really, we handle all government to government consultation in terms of environmental and cultural compliance. So any kind of federal agency, whether it's the Forest Service or the Park Service or the Army Corps of Engineers, anybody also who is using federal funds, like from grants, you have to be compliant with federal preservation laws to make sure that your project or your construction project or your roadway is not going to impact anything that's important to Native American tribes that live there. And so these agencies have to consult with tribes, and I work in an office that handles that kind of correspondence for our nation. And, you know, the footprint of my tribe is 12 states, and we do tons of consultation. Last year, we reviewed over 9,000 projects under this law for compliance. And then I won't talk too much about those because but we also do NAGPR work, which is repatriation of Native American human remains and cultural items that have been excavated from sites over the years, some through the Works Progress Administration or the development of infrastructure in the United States for dams and reservoir building. They found tons of Native Americans all throughout the country, and they were sent to universities for curation and repository. And so our tribe, well, in our office, we work to help bring those people home. Also, I realize I have talked more than 10 minutes now, so I didn't get to go over too many things, but I'm very grateful for the program. And even though I'm not working directly in weed science today, you know, cultural resources are the same as natural resources. And we get to have an opportunity to also hold the tribal seed bank that we just recently got this month. So I do have some plans to start some programs using those seeds and trying to maintain that for the tribe. So I appreciate your time today, and also thankful to see all you, and wish you a good semester.
Okay, thank you so much, RaeLynn. Just hearing about all that you're doing, it shows how beneficial the program is and how impactful it is, not only to you personally, but also how it has gone beyond and helping your tribal community. So as we wind down, I know we have a couple of minutes left. I would like to just thank the speakers, Taymee and Cami, for all the presentations that they had completed, and also RaeLynn. I'm trying to fast forward to the next slide, but the whole point of this bringing everybody together is just to demonstrate the Sloan program. Some of you may not have heard of it before. Some of you may have heard of it, but getting some updated information. But more importantly, we wanted to showcase our Sloan scholars and also Sloan alums to see how they have progressed after they have left Purdue. So with that in mind, we do have a couple of minutes for questions, and we will stay a little bit over if you have any questions you would like to offer. My thanks to everybody, Deb, and to for helping to coordinate the programming, but also to Kevin and Ken for presenting, and also to our speakers. So I will open up the floor now. If you have a question, please feel free to just kind of unmute yourself, and I'm going to stop sharing right now. And there's our contact information. We will share. I'll send out a confirmation email, so you'll have all information there. And with that, thank you. So I will open up the floor.
I have a question, Felica.
Yes, go ahead.
I don't remember whether it was Kevin or Ken mentioned it was a recommendation process. Was that right? Is that the word you used for Sloan recipients? And I'm wondering about more specifically, how that works, how students who are interested in applying to Purdue and possibly being up for this fellowship might connect in that piece.
Should I respond, Felica?
Go ahead, yes.
Sure. So we try to work with students. So I'd say there's kind of the official side of the application process, and that's what I put up on the slide, which was the qualification for us to formally submit an application to the foundation. The student has to have already been accepted at Purdue. But the informal side of that, which is actually more important, I think, is that we work with students pretty early on. So as part of our recruitment, we sometimes have followed students for 3, 4, 5 years, stayed in touch with them, brought them into the program that way. We do a screen of now of students who have applied to Purdue, and then we reach out to them and let them know about the program. And then we try to help them with that process to make sure they know the resources that are here, possibly help them with the application process, and maybe steer them toward faculty who might be, or departments who might be a particularly good fit. And we have a pretty extensive network now since we've been doing this for almost 14 years. So we have a pretty good extensive network across the campus of faculty and administrators that we can reach out to. So I think it's those two things. It's kind of the formal side, but then the informal stuff, that's really the part that happens well before a student gets an application accepted. And that's where a lot of our energy goes, to try to make those connections early. Does that answer your question?
Absolutely, thank you.
Okay, thanks. I don't know if there were any comments in the chat, Deb. I think we just had, okay, no chats. Okay, great. Well, we're going to go ahead and close out the program, and just want to thank you all for joining us today. And feel free to contact us if you have any questions. And with that, I'll go ahead and ask Deb to stop recording, and then we can close out now. So thanks again to everybody. We'll be around if you have any questions, but we do appreciate you coming by and joining us. We will have some additional webinars that we'll be featuring, and we are looking to highlight our Sloan scholars that are across the country, not only from Purdue, but we want to highlight all the other scholars. So we'll have more programming coming shortly. So thanks again, and have a good evening.